All right, for homework last night, you were given 3 points, A, B, and C, the vertices of a triangle. And I asked you to find several things about the triangle. First of all, the lengths of the 3 sides. I'm just going to write this off to the side for now. The length of side AB. Let's see, what did you get for that length, Jamie?
2 times square root of 26.
Good, I got square root of 116.
I got square root of 104.
I did square root of 104. You're right, changing x's 2, not 4. You're replaying it. All right, so yeah, square root of 104, excuse me, good. So square root of 26 units. There we go. I was just seeing if you were confident in your answer or something like that. All right, length of side BC. I'm going to take just a moment longer on this one. Oh, man, it's weird numbers, too. What you got?
Square root of 113.
I got square root of 113. No, there's not. That doesn't reduce. So we'll take a square root of 113 units. And then finally, the length of side AC. Hold on, Jamie. All right.
15.
I got square root of 85.
That's what I got.
He got square root of 85. My turn. All right. All right, so now we're even. And Quentin's ahead. All right, so square root of 85 units. Did you get all 3?
Mm-hmm.
He's ahead. All right, square root of 85 units is our answer there. Questions on the 3 lengths. Again, what is that distance formula, Quentin?
Let's see right there. Okay.
It's the square root of changing x squared plus changing y squared.
There we go. The next thing I asked for was the midpoint of all 3 sides, and I'm going to go ahead and label these on the picture this time. And what is our formula for midpoint, Jamie?
Is the what?
She's like, you're supposed to ask me the distance formula, Mr. Nessie. What are you doing?
Oh, is it the adding both of the x's and divide by 2, adding both of the y's and divide by 2?
Right, so what does that look like in a formula form?
X 1 plus x 2 over 2, y 1 plus y 2 over 2.
There we go. Basically adding x's divided by 2. So for AB, if I add the x's divided by 2, add the y's divided by 2, what do I get for my midpoint, Quentin?
2, 2.
2, 2. For BC, oh man, what do I get, Jamie?
Negative 5 halves 1.
Negative 5 halves 1. And then for AC's midpoint, Quentin?
Negative 3 halves 6.
Negative 3 halves 6 is my midpoint. Did we get all 3 midpoints correct? All right, the next thing I wanted was the slope of each of the sides. I'm going to write these off to the side. What is the formula we use to find slope? Notice lowercase m versus capital M for midpoint. Quentin?
Is y1 or y2 minus y1 over x2 minus x1.
There we go. Now you start to say y1. Notice, by the way, if we set it like this, that actually wouldn't be wrong. The key is we're subtracting, and these have to match. Though this is perhaps the better way because we're used to final minus initial, right, for any sort of change. This is just rise or change in y over run or change in x. But as long as you have the matching letter in the right spot, you're good. Here, technically, addition's commutative. If you put x2 plus x1, that doesn't matter. But here, as long as the x2 and y2 line up, x1, y1 line up, and the y's are over the x's subtracted, we're good to go. All right, so for the slope of line AB, what did you get for that slope, Quentin? 5 is correct. All right, then for line BC, Jamie, what did you get for the slope?
Negative 8 over 7.
Negative 8 over 7, good. And then for AC, Quentin, what did you get for the slope?
2 over 9.
2 over 9. And there's our 3 slopes. Good to go on all 3. Obviously, if you're watching on YouTube and you said, I didn't get one of those, make sure either you figure out what you did wrong, or if you can't figure it out, ask me for help. All right, the next thing was an interesting one. I said, I want the length of the median. Now, again, in a triangle, a median class goes from
Vertex to midpoint.
vertex to midpoint. And so I said I'm going it to go from vertex C to the midpoint of the opposite side AB. Another way we could notate this is D sub CM sub AB. And this means the length of the line that goes from C to the midpoint of AB. And it looks really cool. And so we're going to go from C to the midpoint of AB. And I mean, noticing that the other two midpoints have fractions, aren't you glad I went with this one? Merry Christmas or Happy President's Day, whatever. And so what did you get for the length of that median, Jamie?
Square root of 73.
Good, the square root of 73 units. Is that what you had also? Ooh, not what you had. Did you have the correct median?
Yes.
What was your distance?
10 units.
10 units. So you come up with a square root of 100 somehow. I'm not sure how you did that with a negative 6.5 and a 2.2, to be honest. Because this, I mean, if you messed this up, you might have said 7, which would have been 49, but instead of 3, which is 9. Here, I mean, maybe you say 4, which is 6. I don't know. Interesting. All right, do you have anything else written down but your answer? Did you do it all in your head, or did you do something on paper?
I think it's
All in your head. Okay, so it's really going to be hard to check. But so I guess the moral of the story is quizzes and tests at least show a little bit, so I can give you some partial credit if you happen to get the wrong answer. Does it make sense though now? All right, we got the 3 squared is 9. We got a gap of 8 squared is 64. Yes.
I said 3 is 36.
Oh, you squared the 3 to get 36 instead of 9. Okay. All right. At least we figured out what happened in the head. Now the last thing was really interesting. I wanted you to find the measure of angle B, which is right here. We looked just at the end of the hour yesterday, and we're going to do a lot more with this here in just a moment, but we talked about how to find the angle formed by two lines, and the key was to first find what of each line, class? The slopes. You could then find the, what do we call that angle between a line and the positive x-axis? The angle of inclination. And how do I represent angle of inclination, first of all? Alpha. How do I find alpha? Arctangent of the slope. Now, in this case, since I'm finding angle B, I need both of these angles of inclination. So BC and AB, I need to find the angle of inclination. What is the angle of inclination for AB? Well, we take the arctangent of 5, and I definitely can't do this in my head, making sure we're in degree mode. And what do we get for angle of inclination of AB, class?
78.7.
78.7-ish degrees, 78.69, blah, 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 basically 78.7. And then for BC, what do we get for the angle of inclination?
31.2.
Initially a negative 48, right? But remember, alpha is always between 0 and 180. So I've got to add the 180 here to get 131.2 degrees. By the way, we talked about the angle of inclination and said there's 4 different kinds of slope that go with the angles of inclination. A line that's perfectly horizontal, class, has 0 slope. A line that seems to go like this has negative slope.
Positive. Undefined.
Good, positive here, undefined here. All right, so the angle of inclination for 0 would be 0. Anything with positive slope has an acute angle of inclination. Obviously, an undefined slope, 90-degree angle of inclination. Anything with a negative slope has obtuse angle of inclination, right? I did recommend, in order to really figure out what to do with these two angles, and I think last time we just subtracted them, so that would be a fair guess, I suppose. But if you really want to be accurate, I said one of the best things you could do is draw the sketch kind of on a grid. Did you take the time to try that? Just a quick sketch. Okay, I'm going to do that as well. I'm going to go and erase my distances here to give myself a little bit of room. But I'm going to say, okay, let's actually put A approximately where A would be. Let's put B right about where B would be. And let's put C about where C would be. Now, this is my angle of inclination of AB. That's the 78.7 degrees. This is the angle of inclination of BC. This is 131.2 degrees. But I had said, well, if you were to draw a fake x-axis, then you could see there is also 131.2. There is also 78.7. So there is angle B. And yes, indeed, what do I do to find angle B? Simply subtract away. And what do we get for the measure of angle B?
52.5.
Good, 52.5 degrees approximately. Did either of you happen to have that? All right, it's something that we're going to spend more time on today, but I was just curious how we did. Does it make sense how we got that? All right, any questions on the homework?
Okay, so for the, I'm trying to see how we used the angle of inclination, like how we knew which angles it was.
All right, so we drew the picture, right?
Yeah.
This right here is line AB.
Okay.
By definition, its angle of inclination is the angle that it makes with the
Okay.
positive x-axis. So if this is 78.7, then this is also 78.7. This line BC makes a 131.2 with the positive x-axis, right? So that means that if that's this angle, then that's also this angle, right? But I took this white angle here, subtracted from the big angle, and that left us with the pink angle here, which is actually angle B. Does that make sense?
Yeah.
All right. Tell you what, go ahead and find the angle of inclination for AC. We didn't need it to find angle B, but go ahead and find AC's angle of inclination. And what do we get, class?
12.5.
12.5 degrees. And if we're looking at the sketch, again, we're going to have to draw a fake x-axis. We can see AC has a very small angle here on my rough sketch. All right, questions on that? Any questions? All right, clear your desk except for a clean sheet of paper and a pencil. You're not going to be finding angles formed by two lines on this quiz, okay? But the rest of it, right? Slopes, angles of inclination, midpoints, distance, all of that will be on this quiz. If you're watching on YouTube and want to pause the video and look that over, you may. Unfortunately, my kids can't pause the video. So here we go. We could ask any last questions they might have, I suppose.
Can you go to the pose real quick for the distance and the midpoint?
All right, before you get the quiz out. All right, distance. Change in x squared plus change in y squared, a square root. Midpoint, add the x divided by 2, add the y's divided by 2. Slope, change in y, y2 minus y1, over change in x, x2 minus x1. And then alpha, just take the arctangent of the slope. All right. First, I'll stay with the top of your paper along with today's date, which is 2/18/22. 2/18/22 is today's date. And this is quiz 32. Quiz 32. Let's take a look at the quiz together. Numbers 1 through 3, you're writing some formulas. 4, 5, and 6, answering some questions. Number 7 starts the math, so there's no math on 1 through 6. Number 7, you're going to have 3 answers. You're finding 3 different lengths. Number 8, finding a midpoint based on what was given in 7. Number 9, finding a slope based on what was given in 7. And number 10, finding an angle of inclination based on what was given in 7. Okay, any questions before we start? Go ahead and get started on quiz 32. Should keep your work covered with that quiz copy. Be finishing up in the next few minutes. Spend another minute or so to put down final answers. All right, students in here are finished. If you're watching on YouTube, go ahead and pause the video to give yourself time to finish. All right, page 208 in your textbooks. We're going to work on angles today. Working on angles. And turn your books to page 208, and we did number 4 yesterday, a couple of parts of it. Want to jump down to number 5 now. Go ahead and read number 5 if you would, Jamie.
Draw a diagram, find the inclination of each line, find the smallest positive angle line, AB, makes with line C.
All right, so I want to jump to number 5B, and it gives us A is -4, 1, B is -1, 4, that's one line, then C is -1, 3, and D is 2, 0. Go ahead and draw a rough sketch on your paper. Again, you don't need graph paper for this because it's just a rough sketch. We're not trusting our eyes any more than we did last year. And go ahead and plot about where A would be and then about where B would be. So got a little, very short line segment, admittedly. There's my AB. And then we've got C and D. Now again, if you were just going line segments, these lines don't actually intersect at all, do they? Unless I drew them wrong or copied something wrong. We're on letter B, 5B. All right, so Quentin is nodding that yes, I am correct in saying that these were line segments, they would not intersect. However, we understand the line can be extended indefinitely or limited at any point, so I'm going to go ahead and extend this line up here. I'm also going to extend my AB downward to make sure it crosses the axis. And it starts by saying find the inclination of each line. So I've got my line, my angle A, and then this angle here at D. Do you see that those are my two angles of inclination? All right, how do I find the angle of inclination of AB? Class? Slope, the other M, right? Slope M, right? Yes. All right, so we're going to find the arctangent of the slope, which means we need to know
slope.
The slope. And I don't. So let's find it. Let's go and find the slope of AB. And we get not the length, the slope. It's 1, right? 3 over 3 or negative 3 over negative 3 gives us a slope of 1. So therefore, if we take the arctangent of 1, it's okay. It's a Friday. I know brains in all my classes so far. Everybody's just kind of, we need this 3-day weekend coming up. We'll take the arctangent of 1, we get 45 degrees. So here we have a 45-degree angle. All right, now for CD, I need to find, first of all, the slope of CD. That's going to be negative 1. And so the angle of inclination of CD,
45.
I'm sorry?
45.
Well, it's a negative 1.
Negative 45.
It's going to say negative 45, so we're going to say 135. All right. So it's a 135-degree angle. Now, if you're looking at this as a triangle, we could kind of use a geometry concept, couldn't we? That an exterior angle of a triangle is equal to the sum of the opposite interior angles, these two. Or, extend that maybe just a little bit more, the other method that would work if a triangle were not formed, we could say, well, this is obviously 45, alternate interior to the angle at A. This is 135, alternate, corresponding 45s, and then corresponding 135s. So therefore, the angle between them is the difference of 135 and 45, which would be 90 degrees. So therefore, AB and CD form a 90-degree angle, or we could say they are, if they form a 90-degree angle, perpendicular. They're perpendicular to each other. Right? There's a good word from last year. Questions on 5B. Let's do 5C. Let's do 5C now. We have some different points here. All right, this time we've got A is at 0, negative 1. We've got B is at negative 2, 5. So there's AB. All right, and then we've got this 0, negative 1, B, negative 2, 5. C is at negative 4, 2. And D is at 3, 3. What's the first thing we're going to have to do if we want to find the angle that these two lines make with each other? Jamie? We need to find the slopes first. So at your seats, find both slopes. What do we get for the slope of AB, class? All right, and then for CD, Quentin? The slope? That's the angle. I was just looking for the slope.
Negative 1/7.
Is it negative 1/7? I got a positive 1/7. So we got a 3 minus a 2 over the other 3 minus the negative 4. Yeah, that's going to be 1 over positive 7. All right, so these should have been our slopes then. So from here, once we know the slopes, Quentin, we need to find the angle of inclination. For the record, too, not only is it a Friday right before a 3-day weekend, Quentin also is not feeling well today. So judge him by his usual brilliant self and not by today's struggle. We're just trying to get through and survive. So, all right. No judgment here, Quentin. All right. So our angle for AB, angle of inclination, is... Good catch. There we go, 108.4. And then for angle of inclination CD, Jamie?
8.1.
Oh yeah, 8.13, 8.1 degrees. I almost read 81.3. My brain was ready for the decimal to have 2 digits before it. No, you're right, 8.1. All right, so we want to find the angle that's between them. Now, again, my suggestion would be, if we kind of draw an axis here, we can see this little tiny 8.1 degree angle, right? And we can also see here, we don't need to draw an axis, we can see our 108.4 degree angle, right? So if I draw another axis right in the middle of where they intersect, I've got here the 108, and I've got the 8. So how big is just this angle here? If we take off the 8.1, 100.3 degrees, except it said find the smallest acute angle. You see, there is a 100.3 right here, isn't there? But right up against it, we have the acute angle formed by these 2 lines, right? This angle right here. So let's change and find this angle now, and that would be
79.7.
good, 79.7 degrees, and that's going to be our answer for 5C, right? Questions now that we've done a couple of them. Again, as a general rule, you end up subtracting the angles of inclination. I say as a general rule because there are some weird things that happen from time to time, but just using parallel lines. True x-axis, fake x-axis, another fake x-axis, right? Using some of these lines kind of to serve as guide lines for you. Now let's apply it back to a triangle like we've done before. Number 6, letter A. Go ahead and read 6A, what we're doing here. Quentin?
One side of the angle of the triangle.
All right, so let's go ahead and actually plot these on a sketch. Make it nice and big. Give yourself plenty of room here. And so for 6A, we've got the point 2, 3. So let's just say that's here. We've got the point B. Oh man, I'm gonna wish I wrote that somewhere else. We got the point B is 5, 7. And point C is 4, -5. So I'm just going to change the place that I wrote my A point, so it's not in the middle of this triangle here. Really weird looking triangle. And there we go. Make sure your sketch looks somewhat similar to mine. Again, it doesn't have to be perfect. We don't trust our eyes anyway. All right. Well, the first thing we're going to have to do, if we're going to find the angles of the triangle, we have to know the angles of inclination, which means we're going to need to know the slopes. All right, so let's start by finding the slopes of all 3 sides. Once you have that, find the angles of inclination of all 3 sides. One could argue if you really want to do this right, use memories. Yeah, whatever. Fact check my slopes. Did you get the same 3 slopes? Okay. Angles of inclination now. All right, you'll notice, by the way, these do not add up to 180. Of course, these aren't the angles of the triangle, right? Okay, so, move this out of the way here. A, B, or C? Pick one, Quentin. B. All right, so what I'm going to do is I'm going to start by putting a fake x-axis here. Now, and I'm also going to put a fake x-axis here. That's not a very good x-axis. That's not very parallel, is it? Kind of going downhill. Right, that a little bit better? And we're going to put a fake x-axis here. I'm going to go ahead and label the angles. For instance, the 53.1 degree angle is right here. I'm going to label the 53.1 degrees. BC's 85.2 is right here. I'm going to label that. For that matter, AC's 104.0 is right there. Do we see all 3 angles of inclination? All right, Quentin said, let's find angle B. First things first, if this angle is 85.2, alternate interior, this angle is 85.2 degrees also, correct? But if this angle is 53.1, then the pink angle is 53.1 also. So if I want to find the measure of angle B, I'm going to need to subtract 85.2 minus 53.1, and we get approximately 32. Questions on how we got angle B? I think the easiest angle is got to be angle C. Angle C is just screaming at you right now. What do we need to do to find angle C? This angle right here. Yeah, I mean the 104 and 85.2 are already overlapping. 18.8 when you subtract. Now, if you wanted to cheat the system, how could I find angle A? And subtract from 180. But that robs me of my chance to check my answers, doesn't it? And I don't want to lose that opportunity. Here's the next thing. This angle is 104.0. That means that this angle is also 104.0. Which means that this angle has got to be 76 degrees. So how big then is angle A? $129.1 degrees. Now, let's see if the sum adds up to 180. And it does. It's possible that with roundings that we did, we might have been at, you know, 1/10 of a degree off, maybe 180.1 or 179.9, but it was right on, rounding notwithstanding. Questions on this? Do you see how to use parallel lines, alternate interior angles, or corresponding angles to piece it all together? Another option I suppose we could have done was, had we seen fit to extend the line, we could have said that this, no, that really wouldn't have helped anyway. Never mind, forget what I was about to say. I wasn't about to say anything. The way we did it is definitely the best way. All right. Had a thought, died of loneliness, no, and then I killed it. All right, questions on this? All right, your only homework to do this evening is to do page 208, 6b. So you're going to do the same thing we just did with the triangle, but a different triangle. Page 208, number 6b. Page 208, 6b. And we'll take a look at that in our next lesson. We'll take a look at those quizzes in our next lesson as well. Have a wonderful rest of your day, and of course, a wonderful 3-day weekend.